Hello friends, welcome to this video. In this video we are going to see how to find a maxima and minima of a function with two variables. So this is a simple function, that is 2x square minus 4xy plus y raised to 4, right? So here you can see that it has two minima and it seems like it has one maxima, but it is a saddle point, right? So let us see how do you find a maxima and minima in theory, and we'll also show it in the graphical form so that it is easy to understand all the theories, right? So we have one more plot, that is this one, and here you can easily see that there are two distinct minima, that is called local minima, and two distinct local maxima. So let us see the theory behind. Let us say we have a function z is a function of x and y. X and y are the two independent variable. Now I am interested in finding the maximum value of z or a minimum value of z, right? So the function can have more than one maxima or a minima. The point at which the function peaks and then again goes down, and it can peak at some other point too. Let us see how do you find a local minima or a maxima, right? So if you have function that z is equal to f of x and y, right? So first thing or first step in finding the local maxima and minima is to find a stationary point, right? So stationary point is defined as the point at which the local partial derivatives are zero, right? So that is f of x and f of y, that is partial derivative with respect to x and y, are zero. So this derivative is shown here. So partial derivative of x is defined as this, and it is zero, and similarly partial derivative of a function with respect to y also is zero. So if you equate this equation to zero, then you will find some points, right? Let us say that you have find some n number of points, right? So this point, you can say that these points are stationary points, and let us say out of this point the x coordinate is a and x and y coordinate is b, right? So you have a point or collection of points where you can these points are stationary point, right? So now you have to test whether these points are local maxima or local minima or nothing, right? So the test for this points or the stationary point to be a maxima or minima is this. So this test is called as a second derivative test, and the second derivative test is something like this. So you define a second derivative fx fxx as a second partial derivative of function with respect to x, and fxy is a partial derivative function with respect to x and y, and fyy is a partial derivative function with respect to y. So double partial derivative with respect to y. Now after finding this value at all the stationary point, you have to find a value of d, where d is some number which is given by a formula fxx into fyy minus f of xy square, right? So based on this, you find or you decide whether the point that you are considered the stationary point is maxima or minima or nothing. That is called saddle, right? So the condition for this is, so when d is less than 0, then the point is saddle point, and when d is greater than 0, the point can be maxima or minima. And suppose if xx is greater than 0, then it is called minima, and if d is greater than 0 and fxx is less than 0, then this point is called maxima, right? So this is a condition for maxima and minima with two variables. The theory behind this thing will be covered in my next video. So if you really like this video, please subscribe to my channel. In the next video, I'm going to give the theory about this second derivative test. So what is the origin of the second derivative test, and stay tuned for that. So thank you friends very much for watching this video. Take care. Bye bye.